So let's try solving this system now. So what we're going to do here is we're just going to do the elimination method 3 times. That's essentially what it comes down to for a system of 3 equations, 3 unknowns. So what I'm going to do is I'm just going to take the first 2 here. Because I see that the x's are opposites already, so I don't have to do any work there. I'm just going to add those together and get rid of the x's. So I'm going to have 2x plus y minus 3z equals 0. So I just took this first equation and wrote it down there. And I'm going to write the other one just below it. So negative 2x plus 2y plus z equals negative 7. Then I'm just going to add those together. So again, my x's are opposites, so that gives me 0 there. So this is going to be 3y minus 2z equals negative 7. So now I'm going to take another pair, but I have to use the last one here. This one, because I didn't use it yet, I have to use that one now. So I can use it with either the first or the second one. So I'm just going to use it with the second one here, because it doesn't really matter. Either one I pick is going to be the same amount of work. So I always try to look for the easier one, but there's not one here that's going to be a little more faster, or a little faster. Anyways, I'm going to take the second 2. So that means I'm going to have to take the second one then and multiply it by a 3, and the third one, and I'm going to have to multiply that one by a 2. Because they're already opposite signs, I don't have to worry about signs here. So then when I work that out, I'm going to get negative 6. Now I'm just doing this top one here first. So that's negative 6x plus 6y plus 3z, and that equals negative 21. Okay, and then for the bottom one, I'm multiplying by 2, so that's going to be 6x minus 8y minus 6z equals 14. And now I'm going to take those 2 and add them together. So then my x's are opposites, they're going to give me 0. So I'm going to get negative 2y minus 3z equals negative 7. Now again, for that second pair, I had to get rid of the x's. And my sole purpose for that is now look at what I have. I have 2 equations, 2 unknowns, and the unknowns are the same for both of those. So I have to make sure if I get rid of the x's for the first pair there, for the first ones I add together, I'm going to have to do that, get rid of that same letter for the third one I use and any one of the first or second one I choose to use there. Because now I have my y's and z's equations, and I can get rid of either my y's or my z's. So I'm going to get rid of the y's because it really doesn't matter which one I get rid of. So I'm going to take this one here, and I'm going to multiply it by 3. I'm going to take this one here and multiply it by 2. So I'm going to take this one here first, and I'm going to multiply it out. So that's going to be 6y minus 4z equals negative 14. Okay, and then for the other one here, that's going to be negative 6y minus 9y, and that equals negative 21. So now I'm going to take those 2 and add them together. And my x's are going to give me 0, or my y's are going to give me 0. And then my whoa, hang on. Screwed up here. That should have been a z. Okay. I think I said it right and wrote it wrong. But anyways, that's a z. So that's going to be negative 13z equals negative 35. So now I'm going to take and divide by negative 13 both sides. And I get z equals 35 over 13. So there's our z. So now we have to find our x and our y. So that's not too bad to do. And all we're going to do here is just back substitute. That's an ugly number to work with, so don't get used to looking at nice numbers here. They can be pretty painful sometimes. Okay, so anyways, so now I'm just going to go back to any one of the equations I can use before it. So either this one or this one. It has to be one of those 2 because I just have a y and a z there. So anyways, I'm going to pick this one here. Okay, so I'm going to say 3y, okay, minus 2, and I'm going to plug in my 35 over 13, and that's going to equal negative 7. So now I'm just going to simplify this. Oops. So 3y minus 70 over 13 equals negative 7. So now I'm going to put that over 1, and I'm going to have to times the top and the bottom by 13 because I'm going to need like denominators when I add 70 over 13 to both sides. So then I'm going to get 3y equals negative 91 over 13 plus 70 over 13. So then that's going to be 3y equals, and that's going to be a negative 21 over 13. And then I need to divide by 3 and divide by 3 here. And that's really a 3 over 1, so I flip and multiply. So then my y is going to equal negative 21 over 13 times 1 over 3, and I see those 21 and 3 is going to cancel, so I get negative 7 over 13 for my y. So there's 2 of them. Now I have to get my z. Now I'm just going to do that in this little corner off to the left here, over here, because I'm almost done with this. So I have my x, my y and my z. Now I need my x. So I'm just going to plug it into the top one here. So that's going to be 2x plus, or I should say, minus 7 over 13 minus 3 times 35 over 13 equals 0. Okay, so that's going to be 35 times 3, so that's going to be a 105. Okay, so I really get 2x minus 7 over 13 minus 105 over 13 equals 0. So that equals negative 112 when I put those together. So it's negative 112 over 13. Now I need to move that to the other side. So I'm going to get 2x equals 112 over 13. Then I need to divide by 2. Divide by 2. So that means I'm going to flip and multiply. So then x equals, so then x equals 56/13. So now the way I would put these all together are (56/13), comma, negative 7/13, comma, and my z is 35/13. And there it is. It's a 3-tuple is what they call it, and it's a point in 3 space. There's an x, a y, and a z. So that's the answer.